that we do from the foundation standpoint. So what I'm going to do is I just want you to point out or mention what things do you see with this that aren't following code provisions. Anybody got one? There's a few items here that we're going to pick up. Why don't we start? I'll point you out. How about the anchor bolt spacings? Anchor bolt spacings okay? Okay. All right. Now, that's the question I got for y'all. Which bolt are you talking about? Yeah. So are you thinking that the top bolt's the one, or are you thinking about this bolt being the one? See where I'm going? Okay. You're exactly right. No more than 12 inches off the corner. Now, what I'm pointing out and what I wanted y'all to pick up was while this dimension on that top one says 14 inches from the edge, keep in mind, there's a plate there. It's got a 2x6 plate. So we're 5.5 inches. I'm taking off the 14 to measure this bolt from the edge of the plate, not from the edge of the wall. You see where I'm going?
Yeah.
So it is correct. It is within 12 inches. Now it can't be closer than those 7 bolt diameters, which is 3.5 inches. So it's not within 3.5 inches of the edge of the plate where it starts going down the length of the wall, but it needs to be within 12 inches of that, no more than 12 inches away. And so that one happens to be okay, even though it's marked 14 from the corner. But if this is typical spacing, my concern is going the opposite direction, coming down the wall, and my cursor's disappearing here. If we come down this way and that's 14 inches, then that one's further than 12 inches. Does that make sense to y'all?
Yep.
Yep.
Yeah, because I'd be only, 8.5 inches off of this corner, depending on that 2x6 there, because I'm taking off 5.5 inches. So I'm only 8.5 inches off of the edge where this bolt starts. And then I have to go 6 foot on center, typical. So this bolt we would make a note about to make sure that they understand, hey, better check your anchor bolt spacings. All right. So what else do we see here? How about the footing? We don't have a width on the footing because we don't know what the building structure is, so I can't really check the size of the footing, but we would expect it to be centered, correct, on the footing, and I need how much minimum projection?
3.5 inches.
2 inches.
2 inches on each side. So we, again, since they didn't give us that, they just say it's 16 inches wide. We got 8-inch footing coming down. What do we have for projections? 8 off of 16.
4
inches.
8 inches. So we got 4 inches each side. So now we just need to make sure that the footing is at least 4, and the minimum was
2.
6 in thickness of the
Yep.
footing. So as long as it's at least 6 inches, we're good on the thickness of that footing, which I don't know that they give us that at all. So we don't really have a way to measure that. Okay, let's look at the drain tile. We got a drain tile going around, and it's talking about the drain tile discharges to yard, no open joints, has 3-inch bed of washed gravel. So 3 inches under. Is that okay? What's the minimum?
6.
Under.
Oh,
under.
2 required under, remember?
2, 6 above and 2 under.
Yeah, it was 6 above, 2 under. And so this says we got 4 inches over top, and we needed
6.
6.
Yeah, 6.
So we don't have enough gravel over top of the drain tile. So we would cite them on the gravel. So we need 6 inches there. Okay, let's look at what they have for waterproofing, damp-proofing. And so they're giving me a description here, and it says 8 mil polyethylene, joints overlapped and sealed.
Must be
So
six.
first off, putting poly on it, is that waterproofing or damp-proofing?
Waterproof.
Waterproofing. Remember, damp-proofing was just the coating. Waterproofing is the membrane that gets adhered. Okay. And they're using 8 mil. Is that okay?
The 6,
No,
We needed 6 minimum. So is 8 thicker or thinner than 6?
Thicker.
Thicker. So we're good with the 8 mil. But this is what I'm looking for, correct? All right. Now we get into checking this foundation wall, seeing whether the foundation wall is adequate for the soils. And in the description, they give us things at the top of the page, and it says that we are in an SM type soil. Okay. And you don't, it really immaterial what that soil classification stands for. You just know it's an SM type of soil. So let's look at the wall. First off, with the dimensions they gave us, what is the height of that wall? When I say what's the building height, how tall is it?
oh, I don't see it.
7 foot 8 inch.
7 foot 8 inch. Don't forget the part that's going above ground here.
Oh,
It's kind of hard to read this
I see.
drawing because they got a line to the soil. So they're saying finished grade level, and that's 7 feet from the top of the footing to that. And then it's got 8 inches over here for what's sticking up out of the ground. So it's 7 foot 8 in height. That's a wall height. Now my unbalanced backfill is how much? Remember, that's where
8 inches.
nope,
Oh,
unbalanced
I'm sorry.
backfill.
7 foot.
Okay. 6 foot 8. You got it, Chris. That's exactly right.
Where you
Because
find
I'm
that?
7 feet and I'm going to take off for this
4-inch
4-inch
slab.
slab.
oh,
Okay, are y'all with me? Now
balanced. Yeah.
Now to check whether 8 inches of poured concrete, and I don't see any steel in there, so they're using plain concrete, whether that would be acceptable, we would have to go and check with our tables. So if you will hold on here, let me go to my different, shoot. All right, let me just pull this one up.
I'm still not getting how you came up with.
Okay, is everybody with me so far? Where am I? So now I got 2 different tables I could go to. Remember I told you that's a flat wall, it's concrete, and we could look it up. They're using this table, which is bracket 8. It's 404.1.2 bracket 8. Or I could go to bracket 3 because it was 8 inches thick and it was a nominal flat wall. So either one of them would give me the answer I want. Now, in the back of the book, they used this combination table because, as I mentioned yesterday, this is the table that traditionally, historically, we've always used. So they happen to use this one. But technically, if this was my exam question, I could use the other one and I'd get different spacings of the rebar, but either one of them would be correct. They would have to be correct. So we had 7 foot 8 inches on the wall height. So when I come down and look at the wall height off this table, I got 7 feet and I got 8 feet. So which one are you going to use? Go to 8 feet. And then the wall unbalanced backfill height was 6 foot 8, in which case I come in 8 foot, I've got a 6 or I've got a 7.
7.
Go to 7. Come across. Remember the soil type was
SM.
SM, and I see that here in this middle column. And so when I come down and read for 8-inch nominal thickness, it says I need number 5 bar, half-inch bar, at, or 5/8 inch bar at 41 inches on center. So a plain concrete wall isn't going to be okay. So what they diagrammed, I would have to say this wall at 8 inches won't be able to withstand the soil pushing against it. And we need to change that and put reinforcing bars in there. And they're going to be, again, number 5 bar at 41 inches on center.
John, what's that answer using? You can also use the 404-123 chart, right?
Yep. In fact, let's go up and take a look at it. So I go up to, hold on, one more. Okay, so I'm 404.1.2 bracket 3, which is 8 inch nominal flat. And here again, I got to make some assumptions. Now the wall height was 7.4, so we're going to go to 8 feet. And then I come across and I'm going to be 7 feet. And when I come and read over here, now for SM soil, comes up to a number 6 bar at 36 inches on center.
So either or is correct?
Either one of them would be technically correct. I'm going to tell you, the answer in the back of the book didn't use this chart. So they don't give you this one. But if this was the scenario I painted for you, then technically either one of those works. And remember, well, that's what I'm getting at. On the test, they got to tell you which chart I expect you to use.
Right.
Is this one's calling for number 6 at 36 on center, and the other one is what, number 5 at
41
so-
inches.
So it's bigger and closer in this chart, but it's smaller and more spaced out on the other.
Yeah.
Okay.
And it's where the steel is. Remember that relationship about, is it in the tension member or is it not? Because these were centered. The others were giving me my cover. I needed 1.25 inches of concrete cover between the edge and where the bar is located. So it's toward one side. It was located.
Okay, so the other chart is a different placement.
Yes. Yes.
Okay.
Yeah. That's the sole difference. But back to Chris's point, if you were to get a question like this, they got to tell you, and they would say something like, according to table blah. So I know which table to go to, and then I have to look it up. Realistically, they're going to ask you something big ticket, like it's based, to use these charts to figure out my rebar spacing and type, I have to know the following items. And then you pick the ones that you need, like which ones work. And we know height of the wall, we have to know our unbalanced backfill, and we got to know the type of soil. If I don't know those and the thickness of the wall that I want, then I can't come up with an answer. So you see, that may be your multiple choice questions. I don't know that they're necessarily going to ask you, hey, is number 5 bar at 41 okay? Unless they pointed me to a table and told me per table, blah, 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 is number 5 bar at 41 inches on center okay for this wall. You see where I'm going?
Yeah.
So if they don't, then basically I could use, just like we went through, I could use either one of these tables because addressing that scenario, they both should work. Questions, anybody?
Where does seismic design category come into play?
Okay, for here, your seismic design category is not coming in at face value. What happens is when I start looking at the anchor bolts, when I start looking at, what else is going to come into play for foundations? It's going to be that steel that we have. Remember the horizontal steel. It's going to make another requirement for the 2 bars where we had one in the top ring and one at midpoint, or we had one in the top and then at third points. It changes there, but you got to read the section associated with that directing me there when it's, and they'll be labeled with the seismic design categories. D, it'll say when in seismic design categories, D sub 1, 0, or 2. And I was looking for the specific sections. Let me
It's on
check. Somebody
R-
got it?
R404 .1.4.
1.4. Okay.
Four.
Yeah, seismic design categories D sub 0, D sub 1, and D sub 2. And it starts off with masonry foundations, and then it goes to, in 404.1.4.2, concrete foundations. And then it says in buildings assigned to seismic design category, it repeats those, then as established, and that's per my jurisdictional, and then it gives me more information here, and it puts those limits on what the foundation walls are good for, and then it goes down further into the thickness of the walls. So it's kind of strings on out, but the point being, whenever I see that it's got a seismic design category listed, if it's A or B, you can ignore it, because A or B don't add anything seismically to the design that you haven't already accounted for just by the gravity, just by the weight of the building itself.
Okay.
In fact, wind designs are what drive the train. When I get into C, if it's a detached single family, we're good with wind. If it's a townhouse, then it says I may add things, and it usually groups that with, you have anything in seismic design categories D, whether it's single family or townhouses. If I'm in one of the D classifications, then I may have some additional requirements that are going to kick in. There are up in section 301. Now here's where, again, typically I don't ask you a whole lot of design questions, because that's more of a plan review function. So if you're going for the plan review exam, then I would expect you to know what's in 301. However, for the inspector part, you just need to understand the concepts, because you're looking at what came out of plan review when you're going out in the field. So the idea of what seismic design category I'm in, it's based on ground motion, and you'll see there's shaded charts, and it tells me based on locations what my seismic design categories are per those charts up in the front. So that's a good question, Chris. So what you need to just be aware that, there are different seismic design categories. A and B are the least amount of ground motion, least stringent. On the other hand, D is the more stringent. When you move into anything that's higher than D, if you're in an E classification, and there's even an F classification, depending on other parts of the world, then we have to have it engineered. I don't have anything in the code that's going to help you design it once you get into those classifications. So A and B, it defaults to wind, and we'll see this when we get into the wall bracing section. I'll point that out again. Then C, if it's single family, then you're okay with wind. If you're in a townhouse, it goes with the seismic, and that's classified the same as anything that's a D. So it kind of brings them in. Did that help?
Yes.
Okay. Favor, you had something? Fafer, did you have something?
Yes, sir. In the example, you said it's a foundation wall, and you are looking at the basement wall table.
Yes. Yes. because of being below grade. Now, that's one of the anomalies that we have with the headers in the back there. People look at that and say, well, I've got a crawl space. It's not a basement. So for example, if I went to, you know, a large crawl space, but it's not headroom enough to finish out for actual habitable space, then am I in the right, going to use this table or something else? Well, from the concept of we're talking about a wall that is below grade, that is retaining a certain amount of earth, whether that's a basement inside or whether that's a crawl space inside, really is immaterial. And they just haven't cleaned up that language to say we should label it foundation wall, but they still call them basement walls.
It's labeled as a foundation wall if you look at the drawing.
Okay, then my question to you would be, common sense wise, where would I go to get an answer? If I don't have a table that refers to something similar, then I'd end up having to go to an engineer and I wouldn't be able to answer the question.
I would go table number 404112, which is talking about foundation walls.
404112. So you're going into masonry?
No, it's page 113.
Let me just see what.
Oh yeah, it's masonry. I'm sorry. Yeah.
Yeah. So see, then
Yeah.
you're in the wrong table. And that's what I'm getting at is, you know, make sure you look at the scenario and the question and make sure you're actually answering based on the conditions that you have. Now, I think those that have gone for exams will back me up on this. Jamie would back me up on this. For example, when you read a question, if your first instinct is, I can't answer this because I don't have enough questions, I don't have enough conditions spelled out. If that's what you first think, then you're not reading the question correctly. Because your first instinct may be, oh, well, they didn't give me all of the things I need to know in order to be able to answer this. Yet the questions are carefully worded so that you have the information you need. And what generally happens is, if you think that, you're probably reading more into the question than the question really intends you to read in. And you're thinking that it's trying to send you someplace that it really isn't. So be very careful and scrutinize the question. In fact, that's what we do in our academies, or we focus on breaking the questions down to understand exactly what it's asking us. They throw in things, they're called distractors, which, like the seismic design category bit, they may throw in seismic design category when that does not change the basics of what they're asking you at all. So you don't need it, in other words. But in other cases, it appears as if, well, they gave me 3 pieces and I was thinking they needed to give me 4. Well, then I'm probably not, I'm reading into that thinking it's going someplace where the question really isn't. And unfortunately, I don't have an answer off the top of my head or example off the top of my head that gets us there. But that's kind of what kinds of things you may be encountering when you're reading those questions. Thoughts?
That's very important.
Sorry, I didn't mean to cut you off. I would just say take your time in reading the questions, because I know I hold 12 certifications. And so sometimes you read the question and you think you've read it correctly. And that's where, like what John is saying, you kind of trip yourself up. So take your time. It's not a speed race. Don't assume that you just know it right off the bat. Just, you know, read it, reread it, and read it a 3rd time just to make sure that you're referring to everything that needs to be looked at to get the answer. And knowing that book. Know that book like the back of your hand and you'll have no problems.
Don, did you have something?
Well, only that I've always expressed it as, think of the code book as a law book, and it is the law that you're enforcing, and every word has a meaning. And I, with ICC long ago, wasn't ICC that I helped design these tests, and the distractors were intentional because you need to be reading and with comprehension, and that's what it is. So I always tell all these students that I've taught that the exam is a reading exam, and you have to realize that. And when you get to the table, go back to your question, put a finger on the table, make sure that you're, John said it 100 times, make sure you got the right table, because they will fuss with you.
And again, Jamie's point's well taken, Don's point's well taken. You want to be very critical when you read that and make sure that you have identified all the pieces that were given to you in that question. Like we said, some of those you may not need, but other ones are going to be critical to getting the answer. And don't make an assumption. If you have answer choices where I could manipulate a situation to make one of them fit, yet my question didn't give me the specifics to actually get me there, then you're reading into the question. So the answer that you pick should be able to fit with your conditions in the question 100% of the time. I don't have to do anything beyond to make it work. It will fit based on just the criteria given to you in the question 100% of the time. That's the correct answer. If I have to go, well, I can make it work if I used an exception and they didn't tell you to use the exception, then you're reading into it. See where I'm going? So again, there's those kinds of things you're gonna hit upon. So just be very careful that you don't overread that question. Okay. Any other final thoughts on this example? I know we've kind of gone different places with it, but is that hitting home? All right. Once again, going to answer the question that came up in the chat. You can take in to the exam anything that is bound and copyrighted. If it helps you to take in a dictionary, bound, copyrighted, take it in. But I'm telling you, the answer that you are going to get for the exam, the only place you're going to find the exact answer, we guarantee, is going to be out of the IRC, because that's all they're asking you to take in. So if you want to take the commentaries, you could take a commentary in. Now, that's more things to flip through, more pages, and that means time. So be prepared. If I wanted to take in my IBC for some reason, you could take it in. If I wanted to take somebody else's bound copyrighted study guide, take it in. Yeah. Now there's, again, the more things you take in, the more that you're going to have potentially time manipulation that you're going to have to watch out for. Good? Okay, let me move on to my next section here. I'm sorry, what happened? Where do we go? Okay, the next one is going to be a real easy section, short section. This one's dealing with slab on grade inspections. Now, it could be that legitimate, it's a monolithic pour and we're doing the slab on grade, or it could be an independent slab like in a crawl space or a basement that isn't necessarily tied into the footings. So either case, it's dealing with the same type construction, okay, for this inspection. So what happens is we've only got a few things to look for. They're checking for foreign material, vegetation, getting that out, trash, getting it out before it's poured, my subgrade, which I'm going on, the base material that the concrete gets poured on top of, and then the thickness of the slab itself, and a vapor retarder. We used to call them vapor barriers, but basically that vapor retarder, 6 mil poly or so, that we're going to have between my base and the concrete that's going in. There's a sections here to refer to this inspection, and they're coming out of section 506. Now that is in the floor section. So you got to remember, when I go through my floor section, I start with general, then I go to wood, then I go to steel, then it goes to concrete eventually. So it's kind of in the back. It's right before the deck section. So keep that in mind. Again, flags, notes may help get into it quickly, but 506 only has a couple of sections. Now here's an illustration of our different conditions. It could be this slab that's on the ground that is independent of the foundations. It could be tied into the foundations here on that slab. That's okay. That could be included, but we're looking at 2 tasks: the subgrade, base, and vapor retarder, and then the slab itself. So not a lot of information that's being picked up. When I look at my first task, it's just making sure that we don't have material underneath the slab that we don't want. So that's my sub base. The base needs to have approved drainage material, which is going to be 4 inches thick. I got a 4-inch thick. It can be group 1 soils. It can be, again, a sand, a gravel base, something that's going to drain, move water away. That needs to be at least 4 inches thick. Then we're going to check for making sure the vegetation is gone and that we have it prepared for pouring of my slab. I can go with, and this is in 506.2.1 of the code, it gives me the allowance to use up to 24 inches of sand or gravel, which doesn't mean that I've had to have a compaction test on it to support this slab. I could use up to 8 inches of earth underneath of here, and that would be acceptable as long as it's not topsoil, as long as it doesn't have organic material in it, and those are still acceptable without going to compaction tests. So it gives me some options here for filling in underneath of it for support, which basically aren't telling me that it's been compacted, been tested. If I go more than these depths with these materials, then yes, I've got to have some inspection reports, testing done to show me that it's going to be able to hold up the weight of the slab and, you know, the live load on top of the slab. Okay. So that's a critical section. I would highlight that, by the way, if I were you, just because it's an oddity in the code. So 24 inches sand or gravel, or 8 inches of earth as a fill material underneath of it, and you're okay. You don't have to have them show you that they've got some testing and it be adequate. Then I look at that and make sure that I've got the vapor retarder in place and that I've got the slab itself. So here's an example. We got a slab in a basement or a crawl space here. And so they've got 4 inches of crushed stone. Good there. I'm looking for my vapor retarder, 6 mil or equivalent. We're good there. Looking for 6 inches of lap wherever I've spliced it. Yep, those need to be lapped. And I'm going to have a 3.5 inch minimum of concrete over top of it. Now here they poured 4, that's great, but I only need a minimum of 3.5 inches of concrete over top. Notice the code didn't say I had to have reinforcing wire in that slab. It didn't tell me I needed fiber mesh. It didn't tell me I needed any kind of reinforcement. This is calling for a plain concrete slab, 3.5 inches thick, 4-inch base, 6 mil poly or equivalent. Those are my items, 3 items that I'm basically looking for when it comes to this section. And that's what's permittable as a minimum by code. All right. So that's essentially what these two tasks are involving. In the first case, I'm checking to make sure they got the base. They removed all the stuff, that they put the 6 mil down. If they are using steel, the steel has to be shown in its final form where it's going to end up and supported before I let you pour the floor. So if it's using reinforcing wire, we don't permit you to say, I'm going to stick the wire in as I start pouring it. Or I've got the wire down and then I'm going to pull it up as the concrete starts to set. Doesn't work that way. So once again, it says that my steel must be in its final form before I allow you to go further than that. Here it's talking about the base, again, 4 inches minimum of base underneath. Then it's giving me where I can eliminate the vapor retarder. So this is another section that I would recommend remembering is there. If that is not going to be a space that we're going to finish out later, if we're not going to heat it, we're not going to condition it, we're not going to use it as, you know, permanently habitable space, say it's a garage, carport, or again, small accessory buildings where I'm not going to heat them, not going to put people in them to live, that kind of a thing, then I don't need to worry about that vapor retarder because moisture migration through the slab isn't going to hurt anything. We're not going to get that much of it. But if it is going to be habitable, if it is going to be finished, then yes, I do need to have that vapor retarder there. So this just gives some examples where you could eliminate the vapor retarder. With me. All right. If I have it, I lap them, remember 6 inches on the laps. Then the second part was just looking at the slab itself, making sure that, sorry, went the wrong way. We're looking at the thickness of the slab, and that needs to be at least 3.5 inches. So think of, we typically form it with a 2x4. What's a 2x4 measure? 3.5 inches in height. So that's what I'm expecting in terms of the height of thickness of concrete. 3.5 minimum. They can go more, but 3.5 minimum. And we're looking at that 2,500 unless that table that we use for foundations or footings said, oh, you got a condition where the slab's going to be exposed to weathering and I'm in a really cold climate, I may need to up the PSI on the concrete because of that. So that could modify my exposure conditions. So back to looking at this example, here's checking my base. I would need how much on the base? How many inches? 4 inches. And I need a vapor retarder on top of that. How much?
6 mil.
6 mil or equivalent. And then I'm going to go with my concrete, which is what PSI minimum?
25.
2,500.
And how thick?
3.5.
3.5. That's all you need. That's all that section's calling for. And there is, remember the exceptions for accessory, detached, small areas where I could eliminate the vapor retarder. But once again, the question would have to be phrased to tell you a certain size or meet those conditions if we were going to eliminate the vapor retarder. Yeah. Yeah, that's a construction joint. It does not say that I have to have anything there. It doesn't address it at all. So it doesn't tell me I could, you know, pour this over to the wall, but you do get a difference movement over time. So that may form a crack there. Usually they, you know, put some kind of an expansion joint material in it, but the code doesn't address that at all. Doesn't tell me I have to do that.
What's the most common material?
For what?
The expansion joint that you were just mentioning.
Yeah, there's all types that could be used. Yeah. But again, the key points are code doesn't tell me I have to do that. And if I chose to pour it straight over, yep, that would be acceptable.
John, does a cure time come into play with any of this between the footing, the foundation wall, pouring the slab?
Yeah. Basically, we're calling for strengths at 28 days. So ultimate strengths are developed then. And based on, it's not a simple because of your humidity and, what kind of temps it's being exposed to. But, I'm expecting that I'm allowing it to cure and set before I put another element that is going to be using it for any kind of support or in contact with, so that we don't get a failure on one part or the other because it hardened faster than the other one, if that makes sense.
So if this was not monolithic, then you're saying the footing should cure for 28 days before the foundation wall is poured?
Ideally, yeah, you get 90% of your bearing capacity at that 28-day strength. So you want that to set up and be done before you start pouring anything that's going to rest on it. Verifying the strengths. Yeah, looking at concrete mixture, and then you're, going from there, looking at what it's going to be. And, you'll get different mixes and different PSIs based on the ratio and percentages, and that would be shown up on your tickets, your concrete tickets that you could collect. So you'll see what they're pouring, and then it is, that gives a certain expectation at X date, say the 28 days, then that gets to being able to demonstrate what is its ultimate strength, what it's going to end up at. And that's a critical part. So, anybody else? Questions?
It's not a requirement to wait 21 days per code, correct?
No.
Because you're not going to find any contractor to do that.
Yeah.
No, not realistically.
No, if it's hard, they're pouring.
Yeah. Yeah.
Well, unless they exceed the requirements in chapter 17 of the building code where they're required to have special inspection, then they'd have to wait and they'd do their core breaks. And then that's how you would confirm that they reached their desired strength, because you would get that in the report from the special inspection agency.
Right.
And again, that's pointing at a commercial application. So,
Yeah, John, out west here, we do it, it's all done monolithically, so it avoids everything. Inspector does a footing and foundation inspection all at the same time. And the energy code, we don't need to go in there, but he was asking about the expansion joint, but it might overlap. But typically, monolithically, the contractors don't have to, fuss around with this 28-day.
where you run into issues are, again, cold weather and hot weather concreting,
Yeah.
of, pulling off the forms too fast. And again, there's not a simple, it's got to be. Typically, you're talking 3 to 5 days of the form being in place. Again, that's just a ballpark. It gets modified based on the exact temperatures and humidity ranges that you're encountering. But we get, protection in cold weather, and sometimes, they pull off the insulation and the forms too fast, and then you get spalling of the concrete and it doesn't reach its strength. And so the outer kind of shell, slacks off and scales off, where the interior may or may not set up properly at that point. And that can lead to, problems which may not even show up initially, but show up down the road on it. So there's a whole art to that, understanding what's needed when it comes to the concrete to make sure that it's done properly. So, even applying a rule of thumb is not universal. And that's where the code is, again, expecting that you're going to have to know and understand that, and your contractor is going to likewise be able to pull that information for you. So, cool beans. All right. Let me move into our rough-in inspections now. So that was just getting out the portion on what was the foundations. Now we're moving into the framing portion. So looking at the rough-in inspections, we're going to deal with the framing itself, and it's going to take us all the way through until we get to this life safety or the final inspections there. Actually, it's 11. I owe y'all a break. Why don't we take a short break? If I can I just cut it back to 10 minutes this morning? I got so much to get through. I'm way behind, and I want to make sure I cover as much as I can. So can we keep it to 10 minutes? Please come back at 10 minutes after. Thank you.
Hey, John, are you still up?
No, I'm asleep.
Hey, so this is Jason, by the way. Down here in South Alabama, we do a ton of monolithic pours.
Mhm.
And so a lot of this footing, basement wall, backfill, all that other stuff is new. Is there a course that you recommend? Because it's going to be building a department here, hopefully, over the next 10 years or so.
Mhm.
And this, that portion of it, though I know it's, relative to many areas throughout the country, isn't real relative here, but at the same time, it's required for the test. And so is there a course that ICC offers that might better explain or give a little more detail as to the background of it?
Short answer is there's not a course which is going to be specifically covering that type of discussion. We have what is called an essentials course, and it is IRC essentials, and basically it walks you through the approach the code takes toward construction. It's very generic, so it may be too simplistic in a lot of areas for what you already know. So just keep that in mind as you go through it, but it does walk you through the IRC in terms of its intention. So it would have some of those discussions. This one was intended to point you to the sections and get you through that kind of an approach. There are webinars that we have, some online stuff. I will be honest, I'm not familiar with all of them, but those do likewise walk you through these essential functions. And again, this type of discussion about doing building inspections, that may fill in some of the gaps for you, but I don't know specifically, what you may be looking for. So I
Right,
don't,
well, I mean, it's just, every person is different. So,
Sure. Yeah.
growing up around construction and stuff. Once again, I mean, I've dealt with piling works, once again, which was engineered.
Sure.
Dealt with, I get a bunch of sketches, if it's under
Yeah.
2,500 square feet, I get a bunch of sketches.
Yeah.
And so being able to go in and look at those backgrounds and, and figure out what the footing should be. And like you said, the thickness of the concrete, a lot of times they go over,
Mhm.
well
Yeah.
over, but
Yeah.
somebody who might not be experienced in that, or, hey, I've been, a framer most of my life, I've never dealt with this kind of stuff, that I
Mhm.
might be, training in the next 5 or 10 years. I was just curious if there was something that was going on with that. Something training
Yeah.
them.
Yeah. I can't.
So the essentials and the webinars are actually pretty
Yeah.
pretty good.
Yeah. The essentials class again is kind of, like the entry level intro to the approach that the IRC takes and how it
Gotcha.
handles
Okay.
it, how it addresses those. That may seed it, that plus what you already know, for example, about doing monolithic pours and dealing with those as issues. This is just another form. If you think of that monolithic pour, the trench you have, that is serving as my footing element, which in this case, we're using a ribbon of concrete that is so thick, so wide, and then putting a stem on it, which is the trench part of your foundation that sits on it. And that's either block or that's concrete in simplest terms. And then we're going to frame what's platform framing off of that. So that's usually how the best way to think about it. But yeah.
Gotcha. Okay. Well, thank you
Yeah.
very much.
Yeah, sorry, I don't have a better answer, Jason, but
No, that's all right. Don't worry about it.
okay. Hmm. Hmm.
Right.
Yeah,
Yeah,
that's
no,
a
I mean, that
good
makes
idea.
perfect sense.
That really
Yeah,
is.
it is a good idea.
Yeah. Yeah.
All right. Thanks, Chris. Appreciate
Yeah.
that.
And we love pictures. So you show me a picture, that helps me tremendously to put it and make logic of it. So
Correct. All right. Thanks, guys.
sure. All right. Okay. Where is everybody?
I'm here.
I'm here too.
Cool. And Carla came back from the Belize, from the islands. Cool beans. All right. Gonna start, like I said, I keep saying I'm gonna do this, but we got to pick up the pace a lot. So we're into rough framing now. So if we focus on those components that we're gonna structurally build the building, and now we're going to get to that point where we're putting the interior finishes in, that's going to be what's in this rough in inspection phase. So if you're following in the workbook, it's starting page 77, moving on, it's going to be the rough framing. Now, the first thing they point out is areas where I may have decay or termite protection. Now, this is going to be either exposed wood, which may degrade because of the moisture it's going to absorb and the conditions we have, or it's going to be where we're subject to termite damage. Now, there are tables in the very front that point out where we suspect the termite damage potential is going to be severe, such as Deep South, Gulf Coast region, for example, islands, or where it's going to be kind of moderate. And of course, in the cold, cold north, we don't typically have the same degree of concern. And so that's where it's negligible up there. And based on which region you're in, which is something that the jurisdiction is supposed to tell me which region they're in, but there is a map you can look at in the front of the code, which would give me that information. And I think it's brilliant how smart these termites are. They know to stop at state boundaries. If you take a look at that map, you'll see that it's severe and it goes up. And once you hit that Louisiana border, boom, they don't go over. Well, it's just.
I would have to disagree, John. They're everywhere.
Come on. So, no, say it ain't so, Jamie.
They're non-discriminatory.
Yeah, it's equal opportunity. Yeah. And so this is just pointing out in the codes, and these are minimums. And those that work in those areas do understand that we may need to go beyond the code, beyond the minimum to be acceptable in our region, our jurisdiction. But what it's calling for is where I have, for example, wood framing in those areas, I want to highlight that now I need to make sure the wood has either a naturally durable resistance or that it has been treated in some fashion such that it will now be resistant to either decay or to termites, if those are my issues. Now, the code gives me sections. It's going to have separate sections for decay and for termite protection, 317, 318, my information about where I have probability. Remember, I told you there's a map. Well, it's figure 301.2 bracket 7. So you can look that up in the very front to verify that you're in a region where termites are severe, moderate, or negligible. So having those, there's two subsections. They break the inspection into either decay or termites. Most places, we don't care. We're worried about both, and therefore you are looking at the same things. Now, what happens is it's going to say where you're subject to this, make sure that your materials are the proper materials. As I mentioned, is it material that's naturally durable? And we got a list in the definition section of naturally durable woods. And we have likewise protected wood where it's been impregnated, treated in some fashion. And when you have treated material, whether it's pressure treated for decay termites, or whether it's fire resistant treated, we don't see that much in residential, but we do see it in commercial construction. If you have those, the fasteners you use, the screws, the nails, even the connectors, the hangers, the clips that you're going to use must be compatible with the treatment. And some of y'all probably remember when they first changed from CCA, which is a copper chromated arsenic material, to an ammonia-based, an ACQ type material, they didn't have the ratios accounted for. And so the galvanized hangers were getting a galvanic reaction, just being in contact with the wood, and they would disappear because they have corroded and rusted away prior to the normal natural life of that metal hanger. And then they made adjustments to the ammonia treatment in the wood to now compensate for it. But as an inspector, I need to verify the fasteners and the galvanizing action on them, that it's compatible with the hangers and for the wood based on the treatment of that wood. And what happens is the manufacturers of the wood will stamp on the wood that what treatment is being used, and then the hangers and the nail and screw suppliers will give you what types of treatments they're permitted to be used on. So the hanger will actually stamp on it, or with the product literature tells me that it's acceptable for use with these type treated materials. And that's really the toughest part of the inspection. It has location spelled out, and I'm not going to use the words. I'm going to show you the graphic. So if we have wood that is a floor element or a finished subfloor material, a structural material that is within 18 inches of ground level, exposed ground, then that needs to be pressure treated material or naturally durable material. If I have a beam, which is within 12 inches of exposed ground, then that needs to be naturally durable material. Frank?
Yes, you were saying something about the treatment on the wood. Is it really necessary to have them retreat the one that we cut? Because contractors or anybody that working with the treatment, those type of lumber, whether it's red treatment or green treatment, do they really need to treat it? You know, it reads in the books that they're supposed to treat it back after they
Okay.
cut it.
You're talking about where I make cuts.
Yes.
So if I cut an end, do I need to treat the
Yes.
ends? Yeah, and that's going to come from the product that the treatment product that was used on the wood. So it isn't universal. And if some of y'all are old enough, which I don't see many people my age, maybe Don would be in that category, but we look back and remember when we had creosote and you used creosote. Well, if you cut the end, then you'd look in the middle of the creosote and it was regular wood. The creosote only did the outer ring. And so that was the intention with that code requirement. And early forms of pressure treated material didn't necessarily get the whole thing treated throughout to the core of the material, either due to the density of it or just the pressure treatment that was used. And so to cover those bases with those older materials, it still calls for that treatment. But most modern treatments, it's through the wood now, and no, it doesn't call for you to treat those ends, but you got to be careful and do take a look at the wood and see whether the treatment calls for retreatment where you got those cut ends.
Yeah,
Yeah, John, where we're at here in the South, they use a lot of the blue wood, which is a topical treatment, and
Okay.
manufacturer requires that you know, because when you cut it, then it's white pine, you know?
Yep.
I mean, so
Yep.
to serve that purpose, you have to go ahead and they have to put it in a spray bottle and spray those cut joints. And
Yeah.
that is the reason why I bring this up, John, because of, you know, as I say before, you know, we deal with a lot of modular homes, and they bring in those from out of state, and they send a manual with the home, which we have to read, and that's what the manual is saying to us, that we gotta have them retreated after they cut it.
Yeah. Yeah. And they're, you know, being conservative in saying retreat everything when, again, it's back to what the specific treatment that's used on the wood that may call for it, whereas others may not. And again, there's variety of different treatment products. We all kind of think that get one, it's the same as another, when it really isn't. And if you recall back when we first had treated, and we still have this idea of different grades of treatment. Is it for exposed weather conditions or is it for ground contact? And again, ground contact lumber would, in theory, have a higher amount of treatment and would last longer, whereas exposed isn't made for being constantly wet or in contact with the ground, and therefore doesn't have the same degree of treatment. And we used to call, for example, CCA lumber, you know, it was it a 5-year or 25-year, 50-year life that was expected on the product. Well, that was the amount of treatment and how dense it went into the products. So there's an awful lot of options there, but that's a very good point. We need to check against what the wood calls for and see whether it calls for the retreatment of the ends when you make cuts to it. So
Okay, John. Thanks.
thank you. Thank you. No, appreciate it. Some other areas where we have concern are my wood sills, the sole plate, it's sometimes called the mud sill. Again, I don't know what Carla calls them, but there's a variety of different things. Just whatever you feel like. And we put them, whether they're on top of the foundation wall, whether they're on my slab on grade, but I'm trying to make sure they're not less than 8 inches from the soil. Now, we have again, conditions where wood that is in direct contact with concrete, which is in direct contact with soil. or ground. And those would likewise call for treatments. And again, green plates. Okay, that's what y'all call them. Good. And those are areas, again, unless you've got some kind of a moisture barrier. So if I put a vapor retarder on top of the concrete before I put that wood down, then I could say it's not in direct contact. Now, the argument that I've got a vapor retarder underneath of my slab on grade has not held up, mainly because of the fear that is that vapor retarder actually continuous and not ripped and still in place after you've poured concrete on top of it. And most contractors would admit it's hard to keep that in place without any tears once I pour the concrete on it. The majority of it, yes, is in fact intact and does function properly. But if there are any voids in it, then the question would be, so moisture can move in to the concrete. So now the concrete itself is going to have moisture. And is that going to now be captured or drawn into the wood and possibly cause that to start to decay? So that's the concerns with not putting a actual barrier beneath those wood elements when they're on those slabs, or likewise on a wall would be another one. We have beams that are being pocketed into masonry or concrete and looking for 1/2-inch gaps around the end and around the sides of it, so that again, we get some air movement there to potentially dry it out and to not draw that moisture out of that concrete that it's sitting on or the masonry that it's sitting in. When we have siding, and this could be your sheathing for the wood sheathing behind the siding or the siding itself, this is going to look at least 6 inches of gap there if it's just the wood siding. Now remember, the sill was 8 inches. So siding's coming down below that sill to be nailed into it to provide that degree of anchorage of the sheathing to the sill, which is then anchored into the foundation system. And we're looking for a 6-inch gap there.
John, would that be the same if you were doing a solid pour, where it's showing floor joist there, but same thing, you've got a continuous slab, you got the seal, you'd come over with your 2-inch overhang on your sheathing.
Yeah.
You'd still be looking for that same 6 inches.
Yeah. And that's exactly what. So like back to, whoops, if I can get it. Come on, come back. There. So you're talking about here, like my wood sill at 8 inches separation. And then I got my sheathing coming down and it comes past 2 inches.
Correct.
Yeah, I'm looking for 6 inches of clear from the soil there.
Perfect. Thanks.
Okay. All right. So we had those conditions, and of course, any wood that is directly exposed, decks, beams, pergolas, things like that. Here's where we've got that furring up against my foundation wall, basement wall, crawl space wall. That would likewise be the same concern where it's concrete that's in contact with the soil, same as the floor slab would be. So that's a concern. And looking to see that they're naturally durable or that they've been preserved in some manner. And this is just calling for protection when we bury wood into concrete, like a post. If you were going to put it in and surround it with concrete, there isn't an easy way to prevent moisture there. There's products that you see advertised that can do that or claim to do that. Again, that's a whole nother area which we don't have time for. So moving into my decay protection, here's where, as Frank pointed out earlier, it's got that language about making sure that the ends have been treated if called for, and it references a field treatment and a standard for field treatment there. Our older materials call for that, and some of the modern ones, as Jason mentioned, do still call for those field cuts to be treated because they haven't gone through the whole wood doesn't carry that protection. It's more like the outer shell, more or less, that is giving us the protection method. So termites, similar conditions that come in. There are some options. We can go with treated wood, which is more common. There are soil treatments that are permitted by code. It gives me the termite shields of physical barriers that are permitted by code to counteract that. But generally where I have the termite issue, I generally have the same concerns from the decay resistance. And so we look at a lot of these as going hand in hand, and that's fine. But technically they're two different issues. One is where it's decay I'm worried about. The other one is where I got the potential for termites and the termite damage that's going to come in. So looking at those, just be aware that's 318 for the termites, 317 for decay protection. So those are in, again, the IRC for my different sections. Where you have heavy termite infestation down south, Gulf Coast, those regions, that's where we got to watch out when we're doing the foam for protection from frost movement, and we're burying the foam boards in the soils, because the termites will eat that quicker than they will the wood. It's like dessert to them. They love it. So we don't allow the use of those shallow frost protected footings in those cases. The good news is most times we're not as worried from a protection frost movement issue, but we do have to have something in place there. And so we got to be prepared for making sure that we haven't used foam plastic below grade when we're in those conditions where it's very heavy. And this is just some practices, and in the interest of time, I'm going to let you all do these on your own, check your answers against the back of the book and see what you come up with. Again, just run through the conditions. We got a beam, we're looking for 18 inches, floors, the beam was 12, the floors are going to be 18 inches. So I'm just looking for clearances there. Then you're checking your siding, you're checking your beam, you're checking the floor joist, looking for the sill. Again, I can't really tell what the sill is, but you know, those would be the items you'd look at in that case. And there's my pocket. Oops, sorry. There's my pocket around the beam that doesn't have a gap. We needed ½ inch. And here again, you do run through the examples and try to come up with, are there any areas that you're too close, you got concerns? Okay. Questions? Should be simple. Run through them. Sure. Yeah. ½ inch. Yeah, that's actually for Chicago. That's an older version of a code that was legacy code that kind of remained in. If you think about the fire pockets, that's fire cuts. That's where instead of keeping the end of it square in the hole, what happens is we angle cut it so that if it were to fall away, it won't knock the hole, which would bring the wall down. And it was for party walls. It was dealing with those firewall, party wall conditions where we're concerned about keeping that barrier in place, allowing collapse of the building without taking the wall down or the building on the other side. So that's where the fire cuts came in, but that's a commercial issue, and it isn't called out for as being necessary. Don't even address it in the IRC. Good question. Sure. Okay, now I want to move into floors. So we're looking at floor construction. Now I will tell you the floor construction, we have the same issues when it comes to roof construction. So looking at openings, looking at bearing of wood on wood for structure, for support, those conditions are going to be the same. So when I get to the roof, I'm really going to be flying in the interest of time. So just keep that in mind. Sections in front of each one, check your workbook out, and it'll help you to understand what is being addressed. Lots of information, cutting, notching, drilling. That's a section that you're going to want to keep track of. We'll get there in a minute. And We're going to look at the idea of spans. There's different span tables. Remember how I kept saying with your tables, highlight the header so you know you're in the right table. It's easy to confuse when there's multiple tables next to each other that I chose the wrong table. There's going to be, again, three different floor span tables for floor joist. The first one's going to deal with for residential floors. The second one's going to deal with everything that's not a residential floor, and the third one is for porches. But basically the first one is looking at a load condition for bedrooms where we assume it's going to be 30 pounds per square foot of live load. Now, hopefully y'all are familiar with the concept. A live load is the movable load, the variable load, people walking around it, moving of furniture, things that are going to move in terms of the weight that's going on the structural elements themselves. When it comes to the weight of those materials that are holding it up, those are dead loads. So the weight of my joist, the weight of my floor system, the weight of the subflooring, the weight of the carpet, the padding, the pavers, whatever you have for the flooring materials, those are dead loads. They're constant loads. So I have to account for both of the loads when I look for how far a span of a piece of wood will go. So looking at allowable spans and materials that are being used, I first have to know what type wood are you using, for example. And we'll look at the first one. Let me just run through this before I lose that point. Spans and materials. Then we get into your joist, beams, and girder bearing inspections. Are they resting on an element enough that they're not going to slip off, they're not going to fail, that it's being adequately transferring those loads? And then we're looking at cutting, notching of holes. And if I'm going into a horizontal member versus what we're going to see for the vertical members, like in a wall construction. And then we look at our headers. Then we look at this idea of lateral supports to keep it from rotating. So as I put a element up, think of something that is skinny and tall, and you put a load on top of it. Well, if it's too much weight compared to how skinny it is, it may try to bend, bow, what we call rotate out of holding that load up. And so you may put lateral supports in to brace it and keep it in place. And basically I'm trying to keep it so that it is upright, in place, and holding the loads that are put upon it. So if we have studs that are too long, too tall, and not supported laterally, then they may try to rotate, may try to fail in that manner. And so then we're going to have some kind of, problems with the wall itself. So we look for this idea of joists, and we say, are we putting too much weight on the joist? And are they so far apart from other joists that even the sheathings on the top don't help, and you may get the domino collapse effect if you put too much weight on it. So we put blocking or bracing at the ends of those joists, and you would see that with my rim board, for example, and we attach in through the rim board to keep them upright, keep them in place, and to keep them spaced properly so that we don't get failure. And if we had a truss system, we've got the same thing going on with our trusses up at the top. But then if they are too skinny and too long for the conditions, which the code will have a section which is going to tell you we got to watch out for it, and yet you won't ever come into it in a dressed wood condition. And I'll get there a little bit later. So it's kind of one of those, it's one you may see in a test question, but you would never encounter it in the real world. So I'll point that out a little bit later. So anyway, here's our 6 different sub areas we're going to talk about. So let's talk about this first one. This is looking at the materials. I got to know what the grade of lumber and the species is. So you have to see some stamps to give you that. I'm going to check against my load table, span tables, to read what the conditions are. So we have, for example, here, and this starts on page 100 in your book. We have a example where it talks about a floor joist, and it said the floor joist is in a dining room. Is the dining room the sleeping area?
No,
No. So I would be looking at the table, which is not for sleeping areas. So with that, let me see if I can go back to, and I hope this doesn't take me too long to get there, but I want to, I want to get to
IRC is at page 139.
5. I'm on page, oh no, what happened here? I hit the wrong button. All right. Come on. All right, I apologize, y'all.
It's a live load.
The other thing to keep in mind on your IRC is in the code sections, when you start looking at your chapters, you're going to see illustrations. So in chapter 5, there is an illustration. It is 502.2 for floor construction. That illustration, which I'm showing here, shows you the direction of framing. So if you're in question about where an internal girder, center bearing girder would be located, it's mid-span on the short direction of your framing. So my joists are coming into it. Now, where I also want you to take note is when we talk about openings. So here I've got a fireplace and a hearth where I'm cutting that floor, I'm framing around that. So I have my joists going next to it. The ones that trim the opening are called trimmer joists. The ones that head off joists from going full length, they're called header joists. So what are header joists and trimmer joists? We're going to have different requirements for whether they need to be doubled or whether they can be singled based on the width of the opening that we have. So the code will give us that language, and if you're confused about which one is which, come back to this illustration and it'll help you to decipher. But I see my joist spacings here. I see the sill plate below, and we're coming over, and in this case, they've got a center bearing. So it's cutting down that the joist, half of the joist are bearing on the center bearing, and the other half of the joist weight is going to the exterior walls. So we have to keep that in mind as we're moving through. So what I wanted to get to was, if it'll open up, I wanted to go to my floor framing, and I wanted to go to this table, and where's my allowable joist span? So let me go to 5023. Okay, so there's going to be two different tables, and in this example, they said it was a dining room, remember? So we're non-sleeping. Now the first table I encounter, 502.3.1 bracket 2, notice this one says floor joist spans for common lumber species, but in brackets, and that's what I would highlight. Residential living areas. So we're residential living areas, and it's going to call for 40 pounds per square foot for those. And then it says I've got a deflection. So L over 360 is the amount of deflection, max deflection I'll have. So it will have a 10-pound dead load, and it'll have a 20-pound dead load. Now, if you're taking a certification exam, they have to tell you what the dead load is going to be. But in a typical scenario, unless you're going to heavy floor material like poured concrete or concrete pavers or heavy brick masonry elements, not just normal flooring, tile, or even carpeting or wood floors, those are normally going to be in the 10 pounds per square foot dead range. If I'm going to super heavy floor materials, I may end up in the 20 pounds per square foot. But in a test question, they'd have to tell me, are we talking 10? Or are we talking 20? Because you don't know. And in this case, they were telling us it's 10. So I'm in these first columns coming down. We're in a residential floor, and I'm coming down, and then it says, I've got 11 foot, 10 inches of span. It's a 2x8, and it's 16 inches on center. Now, the thing I need to know is what kind of wood are they using? So the first thing they talk about is using number 2 Southern Pine. So I am 16 inches on center, so I'm not at the 12. I come down to 16, then I go over to Southern Pine, and I look for number 2. So number 2 grade Southern Pine. Everybody with me?
Yeah.
And now I'm going to come across until I get to 16, or excuse me, 2x8s. And so if I look at my columns, that is the second column over. So we're coming over from Southern Pine, number 2, second column over, and it says 11 foot, 10 inches.
11 foot, 10 inches.
Everybody read it?
Yes.
So if that's the clear span I get, we're good. If my drawings called for something larger than that, then that wouldn't work. Now, the idea is that's done at plan review. But if you saw something in the field and say they swapped lumber, and the plan said we're using number
Voicemail.
2. Question? So if my plans indicated it's number 2 Southern Pine that they're going to use, and they chose to use hem fir number 2, well, I would have to check the charts to see, is hem fir number 2 going to be worse or better than the Southern Pine? And it comes up that same conditions, I get 12 feet instead of 11 foot 10. So it is better. It gives me a greater span between supports if I had hem fir versus Southern Pine. Now, once I see that it changed from the approved drawings, I have to make that notation so that there's a record that they deviated from what was the approved plans. And in this case, it wasn't harmful that they did that, but if they went the other way, let's say it called for number 2 hem fir and they bring out number 2 Southern Pine to the job site. Now, when I look at the stamps, it's, whoa, wait a minute. I was expecting to see number 2 hem fir. You got number 2 Southern Pine. When I go and check this charts, I realize if that span ends up being, greater than 11 foot 10, if it was 12 feet, then this is not geared to support that weight that we need to have, in which case they're going to get failed. And now they got to either come in, put some scabs, do something to replace it, get an engineered fix, or put different lumber in. So, sure. Yeah. Good question. That is the unsupported distance. Great question. So if I was on an exterior wall, that would be from where I bear on my mud sill, the inside edge of the mud sill, to the inside edge of the support on that center beam. Or if I'm going to the other wall, then it's, the inside edge. But when we give distances here, they are the clear unsupported distances. So for example, when we get to headers, we're going to give you a clear span on a header. That header is also going to tell me how many jack studs I need underneath of it to hold it up. So I don't have to subtract off the jack studs from that distance to come up with what the clear opening is. That would be the clear opening from inside face of jack stud to inside face of the adjacent jack stud. When I talk about rafters on the pitch, I'm looking at inside face diagonally coming over to inside face, and that's my distance that it gets. What, where those supports are, that's going to be what my distance is that I get per the tables. Great question. Great question. Now, this was, as I mentioned, the second table in this configuration here. So what we need to look for is the one that is going to be for the sleeping rooms, and that's going to be my first table. And why? Let's go to that one. All right. So this one is the first table you encounter, 502.3 point 1, bracket 1, and notice in the brackets it says residential sleeping areas. So just for fun, we had a 16-inch Southern Pine number 2, and remember it was 11 foot 10, 2x8, 10 pounds dead load. This one, it gets me 13 foot 3 inches because I've only got 30 pounds per square foot of live load versus 40 pounds per square foot of live load. So if for some reason I'm looking it up on exam and I pulled the wrong table, I got a lot of variations here. I'm going to be 2 foot or better off. And that's what we're concerned about, is making sure that you have taken the time, like Jamie talked about, read the question, make sure you understand the question, and now go and match up your parts. Don mentioned that. Read the question. Okay, sleeping. All right, table, sleeping. Yep, I'm in the right table. Otherwise, you may be off. But that's the basics, and this works. I'm not going to have time to do it for ceiling joists. It works for rafters, and as I'm going to show you, it's going to work for headers as well. All the same approach. Put your parts and pieces in and see that you've met those conditions. Any questions so far? All right. I'm running up against lunch, and what I want to do now is just show you, while we're here, about the headers. Now, the headers are going to be in the wall section. So what you have is, instead of a header for a floor system, like that interior girder that we talked about underneath the floor system, well, that's going to show up in a chart, a beam chart, but yet it's going to be in the wall section, because that's where they put all the headers. The majority of my headers are going to be in my exterior walls. And the trick there is reading to make sure that you have chosen the header for the right floor that it's located on and not misread the chart. And I'll show you that in a minute. But the key point here is, even though I'm in the floor and I'm looking for a header to size it, I'm going to end up going to chapter 6 and looking in my wall section for those headers. So headers are 602.7. And when I go into headers, and we've got, let me just call that up. Taking a while to get there. Oh, come on, baby. It's going to show us the different header charts. There's 3 that are going to deal with it. And just for clarification, my structural guys, we use the term header, beam, and girder pretty much interchangeably in the IRC. So you don't have to worry about, well, is it technically a beam or is that a girder? Those are commercial applications, and we just use the terms pretty much interchangeably. You've got some kind of an opening, and so I have a member that spans across that opening, which is going to allow me to carry weight on top of it. Okay.
How are you? I'm all right. How are you?
Yeah.
Just listen to rap music.
Okay. If it's an interior girder, it's the second
Listen
one of
to
the
rap
tables.
music.
Yeah, right. I wish.
Can I just mute you for a minute? All right. So yeah, it's going to allow me to use interior girders. That's my second table that I'm going to encounter. And mine is holding up. I don't know whether it's bandwidth issue, what's going on here, but here we go. All right. So let me go down to my headers. So I've got, those are studs. Got to catch up. We'll get there eventually. I don't know what's going on here. It's taking forever. Wow. I don't know. I guess that we got too many people on trying to utilize ICC's access. Maybe that's it. Nah, I'm just kidding. I have no idea what's going on. All right. So if you can get to your code book, or if you can access, which I don't seem to be able to do here, let's take a look at our header tables. And there's going to be 3 different tables. The first one is 602.7 bracket 1. This one is labeled girder spans and header spans for exterior bearing walls. So it's going to be in my exterior wall. So it's got different rows which address the floor that the header is located on. So the very first one that I encounter says it's supporting a roof and a ceiling. Y'all with me? So it's in the top floor. Whether that's a 3-story building, 2-story building, 1-story building, it's in the top floor. It supports the roof and the ceiling. Then the next set down of rows addresses a roof, a ceiling, and 1 center bearing floor. So it's in the floor below the top floor because it supports that floor that's the top floor. Now that floor isn't a clear span floor. That floor comes over and rests on an interior girder. So back to Christopher's point, if I needed to size the girders there, now I got to go to the second table, which is 602.7 bracket 2, and that one is going to give me what are girder spans, header spans for interior bearing walls. So in this case, it's going to say, are we supporting 1 floor? Are we supporting 2 floors? And it is based on the width, and you're going to look at the width of the building, and then you're going to look at what type of material you're using for the header material, and it gives me the span. Back to clear span, and it's going to give me the number of jack studs I need to support that header over that span. So if it was interior, as we had in the second row down, and mine just came up here. Let me just show you on this. So the first one was the roof and the ceiling. You got this little diagram to show you. It's in that wall there, supporting the roof and the ceiling. Then the next one down is the floor below, and notice it has an interior support. So to size an opening in that interior supporting wall, like beams, girders, or just a wall with an opening, I would have to go to the second table in order to get that distance and that sizing. Then the next one down is in the same floor, but the floor, the same story, the one below the top one, but this one is just a clear span floor. So I'm either able to go from exterior wall to exterior wall with a joist or with some kind of a truss or an engineered product. But I don't have a center support in the middle. That's the secret, is making sure you don't choose the wrong row when you start looking at it. Then here we go to a roof, ceiling, and 2 floors. So I'm in either the basement of a 2-story or I'm in the first story of a 3-story in this case, and we have center supports. So it's not picking up the complete floor load. Whereas the next one down, this one goes 2 floors, but they're clear span floors. And I'm still in the exterior wall. So don't ignore these little diagrams. The earlier codes didn't have these diagrams and people got all confused about them. You with me so far?
Hey, John, so I have a question in regards to the, it gives a ground snow load,
Yes.
pound square feet.
Yeah.
Do I just go with the lowest?
Yep. Where you are. Yep.
Gotcha.
Go with the lowest. If you don't have it, you go to the default lowest one.
Perfect. Thank
If
you.
that's not a concern. Good question. Thanks. Okay, decks have their own section 507. So we'll talk about them in 507 if we get there. But yeah, the 507 gives me all of that information separately for decks. Now, floor girders, I'm going to, so you got an opening in the floor, like for large, I don't know, like a mezzanine type thing where I'm looking down. So I got floor system going down and I got an opening in the floor. Is that what you're talking about? Mm-hmm. No, that's the second table. That's what I was saying. So here, notice it's interior bearing walls. So that would be the condition you're talking about, is those center supports. It may not be actual wall. I may be putting in posts to support it, but I'm going to support the floor system there. And whether it's in the floor system, like an opening that is flush, like a flush beam, or whether it's below, what it's looking for is what's the max opening I can get and what supports do I need jack wise for holding that up. So to size what was those center supports, I've either got a 1 floor or 2 floors, meaning if I'm a 3-story building and you have something in the basement that's holding up the basement joists, we don't tell you what that spacing is. That steel beam typically we see across the country for in the basement, we're not giving you the sizing of that here prescriptively. You would have to go and get that. But if it was a first floor, or again, it was 2 floors you're supporting, you can use this table and it will give you that span based on the elements you're using. So for your floor system, Chris, I think this is what you're asking about is these. Does that make sense? And if I had a 3-story structure, basically, then I've got to engineer the basement. Now, if I'm only, let's say, 2 stories max, and I'm supporting those 2 floors, yeah, and it was the basement supporting them, yeah, I could do it. The first floor and the second floor. And they're got a bearing wall coming down. Then this would tell me this is the beam in the basement supporting the first floor and the second floor. But once I go to 3 floors, then I don't have something to size that prescriptively in here. We're not typically seeing that as, built up wood members. You're probably going to get a glue lam. You're probably going to get some kind of engineered piece. And anytime we have an engineered manufactured piece of lumber or an element like a steel beam, that's outside of the scope of the code. So then that's expected. You've got some documentation, some engineering behind it from the manufacturer to tell me what can it be. So if you're going to run a laminated glue beam, glue lam for that beam in the basement to span girder spacings and it's holding up 3 floors, that's fine, but I'm going to look at, show me the weight, show me your calculations, and show me that this beam by the manufacturer will support that. And here's what the support spacings are. But that's specific to the product. That's not going to be generically covered by the code. Make sense? All right, go.
John, I got a question if you got time.
I might. Just before I get to your question, the other table, just be aware, this one is specific to open porches. So it's on the outside of the building and it's just giving me the support spacings for holding up the porch, period. So an open porch, whether it's a like front porch or whether you got a porch on the back and you want to put a roof over it, that's all that we got there. Jason, go ahead.
Yes, sir. So I've got one builder in particular down here that when he does his headers, he will put his header just under the top plate with his jacks there and his crippling down below.
Yeah. So instead of having the cripple on top like here, he's running the header right up against the top plate.
Right. And that's just contrary to everything that I've always seen, is where the header is generally top of your window, top of your door.
Okay.
crippling above it that goes in between. Does it really matter? You know, an engineer, in this particular case, he didn't draw it that way, but,
Okay. Yeah. And not trying to cut you off, but I guess I am cutting you off. And let me see if this answers your question here. Yes. What happens is when you look at the tables, the expectation of those tables that we had was that it was framed the way that you were describing it, that my header is essentially underneath of my top plates. And that if I have crippling down to a lower beam, which is just framing the opening of the window or the door, that would be below the structural header portion. Now, most parts of the country don't do it that way, in which case the header is dropped and there are little cripple studs over top of that header to go up to the top plates. So what happens is by the charts, and this is really drilling in, if you read the charts here that we had, when you look at this, not that one, the footnotes that are attached to it, it's going to talk about having the header basically in contact and not being dropped, in which case it would expect you to have it up near the top plate in the table with the spans we have. And then it's saying, well, if we have to drop it, then we should make an adjustments. And it says here, footnote E, for example, and just bear with me, spans are calculated assuming the top of the header or girder is laterally braced by perpendicular framing. What's that mean? Well, my perpendicular joists coming into it are bracing it, and it's saying laterally braced by perpendicular framing where the top of the header or girder is not laterally braced. For example, cripple studs bearing on the header, meaning my cripple studs above that wall. It says then tabulated spans for headers consisting of 2x8, 2x10, 2x12 sizes shall be multiplied by 0.7, or the header or girder shall be designed. So what that
very
means,
interesting.
we need to basically take this span and we're going to multiply it times 0.7 to come up with the actual span if we drop the header. Now,
Gotcha.
from a practical standpoint, let me explain. I talked to my coworker who's a structural engineer, and she informed me that in reality, what happens is when you look at what practically happens, unless you are talking about something that is several feet or more in dropping it. If we're only talking the typical small cripple wall over top of that header, and we don't have excessively tall story heights like we run into commercially, for example, if we're talking just, you know, normal story heights, we're cutting you off with 8-foot studs, for example, and you're going to run a 6'8" header in opening in terms of the bottom of the opening to get a door or window heights through there. If we're talking about that, I don't have enough room to get a real large cripple wall above that header. In those cases, from a practical standpoint, and this is just rule of thumb, ignore the reduction.
Gotcha.
Well,
I
on
answered perfectly.
that same note, the height of the wall and the width of the opening wouldn't have anything to do with it.
Well,
because
that's
I know we got contractors down here that put them at the top and the bottom because we build big houses. You know, some of your ceilings may be 12, 14 foot tall.
Yeah, and that's what I'm getting at is if you've got 12, 14 foot tall walls where the floor system's going to be, where your ceiling's going to be, and I'm dropping a header down, and so I've got several feet of cripple wall over top of that header to get up to where that plate line's going to be, where the floor ceiling's going to be. That's when it says you need to take this reduction from a practical standpoint. So that 0.7 inches or the 0.7, you know, variation would come into play. But a great question, Jason. Great question. I don't know whether that helped, confused y'all, made sense.
No, I think it makes perfect sense because I mean, the purpose of the header is distribute the load that would normally be taken up by the studs based on that opening.
Right.
But like I said, the way growing up around construction and my dad building houses back in the 70s and 80s.
Yeah.
The standard way of doing it was your header was at the top of your window or your door opening, regardless of the height of your wall. But once again, we were building, 1-story shops, stuff like that. 8-10-foot walls at max.
And again, some of the other things that come into play is this idea of the bracing that's used. We, in older days, in fact, I framed in high school, that was how I earned extra money. And, we sheeted everything with plywood. It was back in plywood days. And when I first started, we were actually doing diagonal board and in our commercial conditions. And then we actually got to, putting plywood up, and you sheeted everything with plywood. Well, that's our continuous sheathing method now from a wall bracing standpoint. And you get some extra supporting there of those walls and elements. Basically, even though I don't have a physical perpendicular element coming over to support that header as it's talking about, or being supported at the bottom of my top plate. And nowadays we have even the rim board as the header, and there isn't a true header underneath of it structurally. It's that rim board holding up that weight of the floor and the system above. So with those conditions, we didn't have them back then, and it was the sheeting that went on which helped contribute to the extra support and strength. And we didn't have, typically we didn't have such high walls, so we didn't encounter those things. It's more toward what happens now as we get more invested in different designs and different things. So any other comments, questions? All right. We got lots to cover after lunch. Again, I'm going to hold you to, let's take 15 minutes for lunch, because I gave you, again, 10 minutes into your lunch hour. And I'm going to be hustling through trying to get as much as I can in the remaining time. You've got a workbook which will walk you through the discussion points. I highly encourage you, especially those going for the certification exam, to do the practices. Go through these activities. Each section has activities. Some of them are really easy. Some may be a little involved. The answers are in the back. If you don't get the answer, or you question why does that work that way, can't de-engineer it like we talked about, please reach out to me, because I won't have enough time to go through everything that's remaining, obviously, in this book in the remaining time. So I want to hit on some big ticket issues, and I'm going to be skipping some slides here. But I hope this is helping to seed the approach the code is taking. Any comments, questions before we break? All right.